Greetings everyone. The title of this presentation is Join, Join, and More Joins. We are going to cover several different types of SQL joins, which is important because joining tables is perhaps the single most important thing that you can learn to master. The types that we'll look at are join, left join, right join, full join, and cross join. Here are the synonyms, and they're really terms that used to be more popular, say 25 years ago. So an inner join is the same as just a join. A left outer join today is referred to as a left join. A right outer join is referred to as a right join. A full outer join is known as a full join. And a cross join takes and computes the Cartesian products between two sets. Indeed, a cross join does compute a Cartesian product. This means that two tables are going to be combined even if they have no common columns. Now, I'll often ask the students, when I have two tables, how do I know what the new table is going to look like? Meaning how many rows and how many columns in the new table. For example, let's look at table A has 3 columns and 10 rows. Table B has 4 columns and 20 rows. What does the new table look like? Well, if we add the attributes, that's going to be 3 plus 4, that's 7 columns. And we times the tuples, so 20 times 10 is 200. So the Cartesian product of table A and table B will have 7 columns, 200 rows, and you can think of it as each row in table A being combined with every row in table B. To illustrate the different types of joins, we're going to need some tables to work with. Now, many times somebody will try to illustrate the different types of joins, but the tables will have a foreign key, primary key relationship, and it renders some of the variations to be unimportant. So, we're going to choose two tables here at the beginning that have no relationship, but the common column that they have is city. So here I have customer ID, first name, city. Let's execute that and see that we have cities including Logan, Honeyville, Pleasant Grove, Richmond, Logan, Hershey, and North Hollywood. The second table will have the same exact structure, but it is concerning suppliers. Now, the second table and the first table, they don't have to have the same exact structure. I'm doing it to keep it simple. So we have supplier ID, the name, and the city, and all of our joins are going to look at joining on the city column. This first query is just a plain simple join, otherwise known as an inner join. Now, as you can see, I have the customer table, I'm joining it to the suppliers table, and I'm joining where city is the same as city. So only the matching values are going to be returned. Let's execute the query. Look down here, and only the cities that are Logan are matching. Now, I only have one supplier from Logan, and that's Burton. And I have 4 different customers. So there's a row for each match. Notice here that we have 4 rows, and that'll be good to make comparisons on the next queries. Let's do a left join. Now, in a left join, I take the left table, that's customers, and what I'm saying is I want all customers to be returned regardless if there's a match on the right side. So when there's not a match, you'll typically see a lot of null values for supplier. Let's execute this one. And note that we do indeed have 10 rows because we're listing all the customers whether or not they have a match. The only rows that have values everywhere and no nulls are those with cities of Logan. So here's Logan and Logan, here's Logan and Logan, here's Logan and Logan. Honeyville doesn't have a matching value on the supplier side. Let's look at a right join. Just to reiterate, the first table listed is customers and the second table listed is suppliers. The suppliers then is the right-hand table. So what we want to return here is everything from the right-hand table, which is suppliers, and matches to the left-hand table, which is customers. So let's run it. And we see that we have values for customers on matching cities, which is Logan. However, when the cities don't match, say Seattle or Burlington or Huntington Beach, then we have nulls here on the left side. A student asked me once, how do I know when to do a right join versus a left join? And the answer is, if there are only two tables involved, as we have in this example, it doesn't matter. In fact, I could rearrange this and put customers here. I could put it on the right side. I could put suppliers on the left and then have that be a left join. So I can rearrange the tables and change the join anytime I want. It's important though that we understand each of these, because when we have more than two tables and we have a left, a right, or a full join, then it really is important to put those in the right order and to understand how they work. The next query includes a full join. So we have customers as C, full join, suppliers as S. This means we want to list all customers regardless of whether there is a match on city or not. We want to see all suppliers regardless if there's a match on city, and we want to show matches where they exist. So just a hint here, when you see an entire row with no nulls, that means that there was a match. If there are nulls on the right side, that means that there were no suppliers in that city. And if there are nulls on the left side, that means there are no customers in that city. Let's execute this and let's look at the answer. And we see again the Logan values for city. There are no nulls for the entire row. Sometimes we have nulls on the supplier side. Sometimes we have nulls on the customer side. So that's an inner join, a left join, a right join, and a full join. The next one we're going to do is a cross join. Again, that is unlike any of the other types of joins we've done, because you don't have to have a common column between two tables to do a cross join. The next example that I'm going to show is a cross join. To do that, and to be effective in my illustration, I'm going to create two new tables. I have a table called colors, and I'm going to have a table called toys. In colors, I have a color ID and a shade, and in toys, I have a toy ID and a toy name. Let's go ahead and create those. And now let's go put some data into these tables. I'm going to do that with some insert statements, and you'll see that I have the colors blue, brown, black, purple, green, yellow, white, and red. In my toys table, I'm going to put a train, a ball, a yo-yo, jacks, a doll, wooden horse, truck, Lincoln Logs. I'm going to put those into the toy table. So we execute it, and now I have two tables. They don't have anything in common. They don't have a common column, and they don't have a primary key or foreign key relationship. So let's do a cross join or a Cartesian product in SQL Server. So it's a very simple query. I'm going to select star from colors, and then I cross join that to toys. When I execute that, we see that we have color ID, shade, toy ID, and toy name. Now take a look at this, because we have blue train, brown train, black train, purple train, green train, yellow train, white train, red train. It starts over again when we get to a ball, a blue ball, a brown ball, and so forth. So we get each combination of colors to toys. So each color matched against every toy. Now I mentioned earlier that with a cross join or Cartesian product that you add the attributes and you times the tuples. So colors has two attributes, color ID and shade. Toys has two attributes, toy ID and toy name. So the answer set has 4 total columns or attributes. Now each table had 8 rows or 8 tuples. So when I times the tuples, down here at the bottom we see that we have 64 total rows. So that gives you an idea of what is a Cartesian product and how do you do it in SQL Server, which is with a cross join. We've done left joins and right joins, but everything we've done so far has been with 2 tables. But the really interesting and sometimes tricky part is to do one-sided joins with 3 or more tables. So I'm adding a new table called employees, and it's going to have a very similar structure to suppliers and customers. As you see, we have a create table statement for employees, and I'm going to insert about 10 or 11 new rows here. Then we're going to do several multiple table one-sided joins so that you can see how they act. Let's say that the objective of this next query is to show all customers whether or not they have a matching city and matching suppliers and employees. So we look at this query and we think that this might be it. It might work because we're doing a left join which says we should have all customers and then matching suppliers and matching employees. However, when I run it, I get the same answer as an inner join. What happened was we did a left join to customers and suppliers, and if it had ended there, it would have shown all customers. But next, this join, the second join, did an inner join between employees and this combination of customers and suppliers. The only thing that they have in common is the city of Logan. So this version of the query returns the same thing as just 2 inner joins. Let's look at another query. Maybe we can get closer to the answer. What if I do 2 left joins here? So if I do a left join customers and I have suppliers and then I left join that to employees, we'll execute it and it looks like it works. I get all customers and then I just get matching suppliers and matching employees. So that worked because I had a left join here to customers and then that larger answer set I left join to employees. I didn't get all suppliers, that's why I don't have the suppliers show up. Next, we can accomplish the same thing with a single right join. What I did though is I moved customers now to the end, and I do suppliers as S, join employees as E, and that's an inner join, and then I right join. That means that I want all my customers and then only matches from this larger join I previously did. If I run this, I get the exact same solution that I got before, and it only took a single right join. Let's say that we want to list all employees and customers and suppliers that live in matching cities. Well, the easiest thing to do here would be to put employees last and to do a right join. So let's run this query, execute it, and note that all the employees are listed and only the Logan ones have values all the way across in all the rows. So this is going to say that we have matching customers, matching suppliers, but all employees. What if we want to see all customers, all suppliers, and all employees? We do two full joins, execute, and notice that right here we see all of our customers. Our suppliers, the way that our answer is set up, is that we see a few at the top and here in the middle, but at the bottom we have a lot of nulls. And then lastly, for employees, they're listed on the bottom row. So if we want to see all customers, suppliers, and employees, the easy way to do that is with a full join. Now in the real world, I often see people doing multiple full joins and then an extensive where clause to filter out rows based on a lot of different conditions. So this video is about lots of different types of joins and how they act in SQL. If you have a strong knowledge of those, you're going to be very good at querying data.